Now, say a proton with kinetic energy 8 electron volt is moving in a uniform magnetic field. Find the kinetic energy of deuteron moving in the same path in the same magnetic field. So, obviously, B is remains same, R remains same, that is the same path. So, we have to get the kinetic energy of deuteron, but there is a relation here, the charge of the kinetic energy and the charge of the charge of the deuteron and the charge of the proton is same, but the masses are different. Deuteron has got the mass double that of the proton. So, let us see here what is the relation between kinetic energy and mass. So, we can write R is equal to 2 m E divided by q b. So, we can write R square q square b square upon 2 m is equal to E. So, here q, b and this 2 will remain same. So, B and R also remains same. So, we can write energy is actually inversely proportional to mass in this case when q, b, r are same here. So, we can write simply energy of deuteron we have to get. The energy of deuteron divided by energy of proton is equal to mass of proton divided by mass of deuteron. So, that is here E d divided by 8 is equal to this is m divided by twice of m, because the mass of deuteron is double that of the proton. So, this m will get cancelled here. So, E d is equal to here 8 upon 2, that is 4 electron volt. So, the energy of the deuteron is here 4 electron volt.